When we burn fossil fuels, some carbon emissions go into the atmosphere and cause warming. Some are absorbed by trees and plants, but most of that carbon winds up in the ocean. And in a way, that's good news, because otherwise climate change would be much worse by now. The bad news, though, is that scientists don't know exactly how much carbon the oceans are storing or how much more those oceans can take. My next guest says it is urgent that we answer that question and has an idea of how we might go about doing that. That idea is inspired by space travel. Anya Waite is an oceanography professor at Dalhousie University and the scientific director and chief executive officer of the Ocean Frontier Institute. Anya, good morning.
Good morning, Matt.
What do oceanography researchers have to learn from the International Space Station?
That's a great question. I think what we learn about the International Space Station is that nations need to work together internationally to solve the problem of climate change. Individual nations working by themselves, for example, observing the ocean to see how much carbon it absorbs, is just not enough. We can't do it on our own, and we need to join up.
And so the joining up would come through something called the North Atlantic Carbon Observatory. What is that?
So what we thought was that we want to aim for a global ocean observatory, but you can't just leap to the global scale right away. So we could start in the North Atlantic. The North Atlantic is an interesting place in the world ocean because it absorbs actually 30% of the carbon that the whole ocean absorbs. So it's a very important place for carbon absorptions, particularly east and west of Greenland. There is these chimneys that carry carbon right down into the ocean interior. So if we start in the North Atlantic, then we can show how nations can come together as a international example, or we're calling it an exemplar, where we can show how the governance works, how much more we learn when we're working together, and we can scope out the real scale of what is necessary to solve this problem at a global scale.
Can you tell me more about the chimneys that carry carbon down into the ocean? That's such a vivid image. What are you talking about?
So in the North Atlantic, there's a part of the North Atlantic when the Gulf Stream moves towards the north, it cools. And that cold water is heavier than the water below it and sinks down to 3,000 or 4,000 meters. That's 3 or 4 kilometers down to the very bottom of the ocean. And then it stays stored there for about 1,000 years. So if the carbon that is absorbed at the surface from the atmosphere, from the carbon that we've pumped into the atmosphere, is carried 3 kilometers or 4 kilometers down into the deep ocean, it stays there for long enough that we can consider it sequestered or buried in a way. So those chimneys, there's a few of them in the Antarctic Ocean as well, but the 30% of the carbon that the oceans absorb occurs in the North Atlantic.
And that's that's the definition of a carbon sink in some ways, if you're able to do that.
That's right. So if the ocean can absorb the carbon from the atmosphere and hold it long enough that it doesn't outgas, then that's a carbon sink.
And so you're not going to build like a spaceship out of the ocean. You are going to have, hopefully, the global community work together to try and answer some questions. What are the questions that you want to answer?
The main question is, how much longer is the ocean going to continue to absorb carbon? And what are the risks of catastrophic disruption of the ocean carbon system? So many of the models that work internationally, so these computer models that generate projections of what's going to happen in the ocean, they suggest that the ocean carbon sink is going to gently decline. But what we know is that extreme events are increasing in frequency. And if you had extreme events in the ocean occurring, that could disrupt that gentle decline to the point where it seriously changes the carbon absorption. And that type of event could completely overwhelm any of the carbon emissions reductions or management that we're trying to do on land. As an example, critical tipping points in the Arctic, a melting Arctic, acts like a sort of a Zamboni, if you will, and covers the North Atlantic in fresh water so that those chimneys don't operate as well as they normally would. If that happens at the same time, then we get, say, a collapse of an Antarctic ice sheet. We don't actually know what the probability is of those things happening. So it's hard to predict how that massive event joining up would change the carbon sequestration of the ocean, the carbon absorption of the ocean. And it's that lack of knowledge that is the critical problem for oceanographers and observers.
And again, if the oceans were to store less carbon, what would that mean for us here on land?
I think it completely changes the timescales on which we have to act for climate change. We're already in an urgent crisis where we only have 8 years left at current emission rates before we cross that threshold above 1.5 degree warming. It could drastically reduce that time. On the other hand, if the ocean changes are different than that, let's say we find out that the ocean absorbs more carbon than we thought, it might give us those precious extra years to enact difficult legislation or to stabilize our own carbon emissions literally to save the world.
You said that Canada's most important contribution to the fight against climate change could be taking a leading role in the North Atlantic Carbon Observatory. Why is that the case? Why is it that we are so well positioned here?
So Canada is a strong observing nation. Oceanographers in Canada have for decades been among the top in the world doing this work. Canada is also a nation that has shown climate leadership in the international arena before, in meetings in Nairobi and others. Canada is highly regarded in the international community scientifically and in terms of its climate policies. I think this next step would bring together nations in a diplomatic way to show what can be done internationally. And that takes a nation with confidence. It takes a nation with strong scientific backdrop. And it takes a nation that has a sort of a courage of its convictions to step up into the international arena.
Just finally, is your sense that the world is willing to pull together to look at something like this? In some ways, people have said that one of the reasons why we don't know as much about the oceans is because we're here on land and it's out of sight, out of mind. And that could lead to an impasse when it comes to that collaboration as well.
Well, we're land animals, Matt, and that means that we only think about land. But the international ocean observation community is coming together now more than ever. I head the Global Ocean Observing System, which pulls together all observers internationally. And we are coming to consensus that this is the right answer. So the international community is stepping up very quickly to think about how this could work. And I believe we will have shortly a consensus to take to COP27.
And if we don't, again, the urgency that you've spoken about seems heightened even more if that collaboration doesn't come to pass.
As far as the scientists are concerned, it has to happen. Scientists collaborate internationally all the time. We just need to convince our governments to do the same.
Anya Waite, it's great to speak with you. Thank you very much.
Thanks, Matt.
Anya Waite is an oceanography professor at Dalhousie University and the scientific director and chief executive officer of the Ocean Frontier Institute.